For the slightly soluble compound calcium phosphate, the molar solubility is 3 times 10 to the minus 8 moles per liter. Calculate the KSP for this compound. So calcium phosphate solid slightly dissociates into 3, let's do calcium first, into 3 calcium 2 plus ions and 2 phosphate 3 minus ions. Okay. And we know that KSP then is the concentration of the calcium ions cubed times the concentration of the phosphate ions squared. So we know that given this molar solubility, this is tricky because neither one of these is a 1-to-1 ratio with the calcium phosphate, which is different from some of the other examples we've seen. But we know that 1 mole, in 1 liter of calcium phosphate, there are 3 times 10 to the minus 8 moles dissolved. Ca3PO4 per liter. And we also know, based on this reaction down here, there are 3 moles of calcium ions per 1 mole of Ca3PO4 2. So 3 times 3, this is 9, times 10 to the minus 8th moles of calcium ion per liter. And then we do the same thing for the phosphate ion. So we would take that 3, so let me box this because we need this value. So we need, I'm going to start with this same 3 times 10 to the minus 8 moles of calcium phosphate per liter, and multiply that by 2 moles of phosphate ions per mole of calcium phosphate. We get 6 times 10 to the minus 8 moles per liter of phosphate. So let me box that. Okay, those values need to be substituted into our KSP expression to find KSP. So I'm going to erase here because we've written this down. I'm just going to focus on these boxed values to say that KSP is equal to the calcium ion concentration, which is 9 times 10 to the minus 8 moles per liter, and we need to cube that, multiplied by the phosphate ion concentration, which is 6 times 10 to the minus 8. We need to square that. And from here, it's just a lot of algebra. But if you put this in your calculator, you get 2.62 times 10 to the 36. So not very soluble at all. Very, very small value for KSP.